Knock, knock.
Who's there?
A discombobulator of chemical bonding.
Oh no, what's your confusion?
I don't understand ionic and covalent bonding.
That's no problem. I can explain that. The way ionic bonding works is it's the transferring of electrons from one atom to another.
What?
For example, if I had magnesium and nitrogen, they would create magnesium nitride.
Oh, how did that happen?
Allow me to explain. Magnesium has a 2+ charge since it has 2 valence electrons, meaning 2 in the outermost level of the atom, and will be giving those away. Nitrogen has the 3- charge since it has 5 valence electrons and will be receiving 3. Remember, an element needs 8 valence electrons to be stable.
Except for hydrogen, which needs 2.
Magnesium gives its 2 electrons to the nitrogen, stabilizing the magnesium, but nitrogen only has 7 electrons, so we get another magnesium and stabilize the nitrogen.
So now is everybody happy?
I'm afraid not. We still have an unstable magnesium, so we get another nitrogen. Magnesium gives the last valence to the nitrogen. Once again, magnesium is stable, but nitrogen isn't. So we get one more magnesium, it gives its 2 to the nitrogen, and both atoms are stable. IDE is added to the end of the nonmetal to make it an official ionic compound.
So what about covalent bonding? Is it the same thing?
No, silly. Unlike ionic bonding, covalent bonds share electrons.
So does that mean they come together?
Yes, covalent bonds are between nonmetals only. Say we're trying to make carbon dioxide.
Oh, pump your brakes. Does that mean there's 1 carbon and 2 oxygens?
Yes, yes, yes. In covalent bonds, there are prefixes to identify the number of elements.
How many electrons do both elements have now?
Well, in carbon dioxide, we know there is 1 carbon containing 4 valence electrons and 2 oxygens with 6 valence electrons each. Since all atoms will be conjoined, each oxygen will connect to a pair from the carbon. All atoms are stable, and this is officially a covalent bond.
I didn't know how strong the bond is.
The strength of the bond is determined by the element's electronegativity.
So is that where polar and nonpolar comes in at?
Exactly. Polar covalent bonds have unequally shared electrons, while nonpolar bonds share equally.
So does electronegativity have different bonds?
Of course. Determining the bond is done through subtracting the electronegativities for the difference. If a bond is less than or equal to 0.3, it is nonpolar covalent. If it is between 0.3 and 1.7, it is polar covalent. Any bond greater than or equal to 1.7 is ionic.
Ooh, I know this part. Watch this.
Oh, look who's got the hang of it.
So is that everything?
Yes, except one thing. I'm gonna need those potatoes back.
Here you go.
Thank you. I didn't do it right. You gotta say.
I forgot.
I forgot. An electron needs.
No! I don't understand the. Wait!
They make molecules.
Oh, pump your brakes. Hey!
I don't know what I'm doing.
Oh, I know this part. Watch this. It's so